Hi there. Today we're going to talk about running timing tests on the 1031 Systems Animator board in the Raspberry Pi Pico and MicroPython. So what we've done is we've set up a number of animations that we're going to run just to compare. And those are in our animlist file. We have one called animlist.test here. This we copied over to the SD card. And this is what's in it. We've got 3 animations we're going to run. Each one will run both a binary and an ASCII mode with CSV, comma separated value files. And we're going to compare how the timing of these 6 runs matches each other. Alright, so to do that, you can use Thonny and open the bottom window. I'm not fond of Thonny. I like R shell, because it's all command line driven. So we'll run R shell, REPL, and it will connect to the Pico. Once it's done that, we can start running some tests. First thing we'll do is we're going to import OS and run os listdir /sd/anims. So this is where the animations are that we're going to play. And we'll see in there, here are our animation files, and there's the animlist file that has that same list we just looked at up above. So when we run our main program, it's going to look in animlist to see what particular animations you want to run. And you'll notice I can run both binary and ASCII animations if they're in an animlist. Alright, so the first thing we'll do to actually start running our tests, we import main, because main is our main program. Once it's imported, we're going to set it to be more verbose. So we'll set verbose equals true. Now you just run it. Now, once you've run it, this is the same thing as clicking the run button on the Pico, on our system. So now we're ready to actually run an animation. So you can see we have a list of the animations in the order they're going to be played. So we'll hit run, or the trigger button, not run. And it says we're playing the MyRaven binary animation. Now this moves a single servo to move the jaw on a skull. And you saw this on the phoneme timing video that we produced earlier that's available, where you found this one. Now you don't necessarily have to run it all the way to completion. You can stop it earlier. But once it's done, it will print out some statistics. So the key statistics to look at are this line right here. We're averaging 7.3 milliseconds per cycle. Since we have 50 hertz, that's 20 milliseconds per cycle. We're only using 7.3 of the 20. We're way under. That's great. The other important thing up here is our skip count. If our skip count is non-zero, that means that we skipped particular cycles. So the software tries to keep up by saying, okay, this is the current time. This is the time of the next line of animation state I need to play. If my time is too far ahead of that, behind it, I mean, after it, then I'll continue reading additional lines of animation control. And once I reach the right time, then I'll start playing. So it skips ones if it's running too slow. It gets behind. So what we see here, skip count 0, that means we're not getting behind. 7.3 milliseconds per cycle is good. We did get one maximum one of 36.5 milliseconds. That happens typically when garbage collection occurs. It's kind of random. It doesn't usually affect the skip count off much. Sometimes it does. But we'll go on and we'll see what some of the other ones look like. Okay, so here we've run it with the binary mode. Now we're going to run the same animation in ASCII mode. Click Start button. It's running. We're running the CSV version. Will it run to completion? But again, you don't really have to run to completion. You can just let it, you can stop it after 5 seconds or 10 seconds or so, and you will have collected enough data to get an idea of what the cycles are doing. All right, so as this one completes, we'll look at its timing. We'll see it's 7.8 milliseconds per cycle. Not much worse. A little bit higher on the maximum cycle duration, but the skip count is still 0, so we're golden. But we're only running one servo. So let's see what happens if we run 8 digital channels and one servo. That's what we did in our meter animation that we did with the amplitude-based tools that's available in another one of the online videos that you've already seen. So we'll run this one, and it's running the ASCII version, so we expect that to be the slower version. And we'll see, yeah, sure enough, it's taking 11 milliseconds per cycle. That's significantly more than the one servo did, but it's still well under 20 milliseconds, so that's okay. Our skip count's still 0, so that's good. So now we'll try it with the binary form. So we run the same animation. We're using the binary control file. It gets done. Look at that, 7.7 milliseconds per cycle. So we're back in the same ballpark as we were with this one servo. Skip count still 0. That's great. So you can see that the binary form runs faster, but you can run 8 digital channels and a servo and have it run well under 20 milliseconds, 11 milliseconds up here, in either ASCII or binary mode. And we're golden. But now we're going to take a look at what happens if we run 8 servos at a time. So now we'll run 8 servos, and we're going to use the ASCII form. And we look at the 8 servos, and we see now we're running 18.7 milliseconds per cycle. That's getting really close to our 20. So clearly 8 is, I wouldn't even call it the upper limit. It's a little too high. You don't want to run more than 6 maybe in ASCII mode. And our maximum went up to 53, and our skip counts too. So we did skip a couple of cycles. Not a lot, but a couple. All right, so let's see what happens if we run it in binary mode. Yes, we're running the binary mode this time. And so we're running 8 servos again. And we look at the end, and we're at 10.6 milliseconds per cycle. So that's way under 18 milliseconds per cycle. It's still a very good number. Our skip count 0. And our maximum cycle duration 40. So it's clear that when you start running higher numbers of servos, higher numbers of digital channels, you're not going to want to use the ASCII CSV form. You're going to run the binary form if you can. That's to keep you under that 20 millisecond cycle and keep you from skipping cycles. And that's how you run timing tests with our system.